Hi, everyone. Welcome to the Fire on the Mountain talk. Do you feel like I probably need a microphone for recording. Okay. My name is Charlotte Cadow. I work with the Nature Conservancy. I get to be based here in Jackson, where I work as a community science specialist. Much of my work focuses on engaging with the surrounding landscape, like the sagebrush steppe. And so when my colleague, Monica, reached out and said, hey, Mountain Towns 2030 is coming to Jackson. Do you have anything that we could talk about? I immediately thought of how invasive annual grasses are changing dynamics in the sagebrush steppe and how deeply that's linked to climate change and to carbon emissions. So today I'm here to talk with you about cheatgrass management in Jackson in Teton County and how that's affecting both our human communities but also our ecological communities here. So, before diving into the nitty-gritties of the project, the Fire on the Mountain project, I want to start briefly by introducing TNC, or the Nature Conservancy's 2030 goals. TNC is a large organization with global reach, and the 2030 goals are pretty ambitious, but the ones that kind of relate to what we're talking about here today include conserving 650 million hectares of land, and then also avoiding or sequestering 3 gigatons of carbon annually. When we bring that down to a more local level, here we are in Wyoming, where all of our Western priorities kind of come to meet. So in the blue, we have the Colorado River Basin. In the yellow, the Northern Great Plains. The orange is the Greater Yellowstone ecosystem, and all of the areas shaded green are Western dry forests. And then nearest and dearest to my heart is the sagebrush steppe, which is the large polygon outlined in brown. And the sagebrush steppe includes most of our mountain communities. When we look at the sagebrush steppe, it looks like a pretty large ecosystem, but when you start thinking about the rate at which the sagebrush steppe is changing, we've seen over a 50% decline in that ecosystem in the last 100 years. And we're continuing to lose an average of over 1 million acres of sagebrush annually. And so it's an area where there's a lot of potential for conservation, but also for above ground carbon storage. This slide narrows in our focus to just that polygon of the sagebrush steppe. So on the left, we have annual grass cover, one of which is cheatgrass, within the sagebrush steppe in 1988. And then over on your right, we see 2018 sagebrush cover, annual grass cover. I want to point out here that Wyoming has relatively low cheatgrass cover, especially in the southern, central, and western parts of the state. And that is closely tied to TNC's approach that's called Defend the Core. So Defend the Core is a framework that we employ at TNC, and it's all focused on defending core ecosystems. Instead of just going to degraded areas, we try to protect what's still intact. That's where the most bang for our buck comes, and it's where we can make the most difference. And so in Wyoming, we have this incredible amount of sagebrush that still exists on the landscape, where there's low-level cheatgrass invasion. And there's a lot that we can do to protect and conserve the sagebrush remaining on the landscape. While today I'm focusing on cheatgrass and sagebrush, I want to emphasize that Defend the Core can be applied to most ecosystems, whether you're thinking about invasive species management, wildfire management, or prioritizing conservation efforts. Defend the Core helps to ensure that ecosystems remain resilient in the face of climate change. Okay, what is cheatgrass? Has anyone here never heard of cheatgrass? Awesome, love it, okay. So cheatgrass, to introduce you, is pictured on the upper left. This is cheatgrass once it has set seed, so it's all dried out. Cheatgrass is an invasive annual grass that's native to Eurasia, and it poses a significant threat to ecosystems across Western North America. There's a lot that I could say about cheatgrass. It's been heavily studied, but the important takeaway is that it matures quickly and early in the spring. It develops shallow root systems that allows it to compete with natives for nutrients and for water availability, and then it quickly dries out. It turns this kind of reddish color that often shows up on aerial imagery and allows us to detect it from aerial imagery. But then it turns a tan buff color as it dries. And because it dries so quickly in the spring, and because it's so good at competing, it creates these dense, flammable mats. And when there is an ignition, cheatgrass readily spreads fire through these systems. A stat that really hits me hard is that in the sagebrush steppe ecosystem, historically, we've had a wildfire return interval of every 50 to 300 plus years. In a system that's heavily invaded by cheatgrass, we're seeing as little as every 3 to 5 years. Cheatgrass does best at invading in areas that are disturbed, like roadsides or rangeland, or something I've been seeing recently is like the edge of roads going up ski areas. Without some sort of intentional management, cheatgrass is really good at invading. And with climate change, with warmer and drier climate, it's better at invading areas that historically it's been out of. So like Wyoming, Montana, Idaho. It's spreading into these ecosystems. And that is daunting, but it's also like, hey, what an incredible opportunity for intentional management and for community resilience strategy. Okay. One more thing before jumping into more positive and action-oriented content. The areas that are often invaded are hillsides and buttes that are disturbed. And in a place like Jackson, those hillsides and buttes tend to be where homes and infrastructure occur. And so I heard someone sitting up here in the front row. This fire pictured right here was the 2019 Wildlife Museum fire. It was ignited by a lightning strike and quickly took off, spreading up the hillside. And there are a lot of homes on that hillside. Luckily, with the help of local fire EMS, that fire was quickly extinguished. But there's going to be more instances of cheatgrass-fueled fires without intentional management. And so my colleagues at TNC were like, wow, a fire happened. How could we use this landscape as an opportunity to do an experiment that informs management so that we stop this cycle of we have a native ecosystem, cheatgrass invades, fire happens. The cheatgrass is an annual plant, meaning that it has a 1-year life cycle, and the seeds persist for 6 to 7 years in the seed bank. So native vegetation disappears, cheatgrass continues to invade until it becomes a monoculture. How can we stop that cycle? How can we keep cheatgrass below 5%, which is our threshold level that scientists have determined? This is the point at which we can still manage cheatgrass. Oops. Okay. Coming back to the Wildlife Museum burn, it's pictured over here on the left. That's the full extent of the burn area. The museum itself was also quite threatened by this fire, and luckily, it was ended up being fully unaffected. But our study site is just above on the hillside here. I want to really, before diving into the specifics of the study, I want to highlight that this is not an isolated, the impacts of the study are not isolated to that hillside. In Jackson alone, and in Teton County, Sublette County, Bridger Teton National Forest, we're dealing with this cheatgrass issue. And so different weed and pest and invasives management specialists are trying to figure out what the best approach is. And ultimately, it comes down to a couple different herbicides, imazapic and indaziflam. So imazapyk and indaziflam both help to manage cheatgrass levels. But in Teton County alone, we've now sprayed over 25,000 acres of indaziflam. That is not a small amount of land. And so there are a lot of potential side effects of spraying herbicides. For me as a plant biologist, I'm like, well, what's going on with the native plant community? So that's what our study is. Before switching to the next slide, this isn't the best map, but all of the areas with like this lightish yellow color are areas of cheatgrass invasion. And then all of the areas outlined, and you can kind of see it orange, are areas that have been treated. And this is an outdated map, so we've since treated even more. And then on the upper, that red dot up high is the museum where our study site is. Okay. Don't get overwhelmed by this slide. This is the scientist in me being like, I have to quickly mention our methods. So here is our field site. Super beautiful, overlooks the valley. But you can see it's all grass. Our sagebrush is pretty much gone in this area. So within that burn scar, we established 3 1/3 acre blocks. Each block has 6 plots, and 2 of each of those plots are sprayed with the same herbicide. So we have 3 herbicide treatments. We have the untreated is a herbicide treatment. It's our control. Imazapyk, which is an older pre- and post-emergent herbicide that's shorter lasting, has been found to impact not only grasses but also native forbs, but that's ecosystem dependent. And then indaziflam, which is a newer herbicide, and it's pre-emergent, more grass specific, but it lasts for a long time in the soil. So we at TNC were like, wow, what a great opportunity to better inform land managers about the impacts of using this herbicide and how they can help to steward the land to promote native plant restoration, not just cheatgrass suppression. And so the other part of our study is seeding natives. We have 11 different species in 4 seed mixes. The first seed mix is a control, so no seeds. But seed mixes 2, 3, and 4 have these same 11 species. I believe it's 4 grasses. Yeah, 4 grasses and 7 native forbs. Seed mix 2 is a commercially available seed mix, so like Wind River seeds or Stevenson seeds. Seed mix 3 is Grand Teton National Park, so seeds that were only collected locally. Seed mix 4 is a mixture of those two, because the commercially available seed is a more, it's coming from a warmer and drier climate. So we were wondering, hey, if we took local seed and added some seed from more like warmer and drier areas, is it gonna do better in this changing climate? So we seeded all of the plots. I guess I should back up. 2019, fire. 2020, herbicide applied. 2021, seeding on half the plots. 2022, seeding on the other half, to see if there's a difference between what year you seed in. And then additionally in 22, we were like, well, this isn't complicated enough. Let's throw another variable in there. So we added deep furrow plots. Deep furrowing is a newer technology. It's quite simple. You dig 5 to 7 centimeters below the soil horizon, about 4 centimeters wide, and you broadcast seed directly into those furrows. The theory is that you're getting below the herbicide horizon, and that allows for native plants to emerge. And after all that, we started monitoring. Okay, monitoring. What does that actually look like? We were looking at cheatgrass cover, native plant cover, native plant diversity, seedling emergence by seed mix, seed year, and treatment, so broadcast versus deep furrow. What does that actually look like? It's about 4 intensive weeks on your knees looking at plants, which I think is pretty great as long as it's not like 95 degrees. I'm gonna walk you through some of the simple results. It's a pretty tangled story once we start getting a little deeper into it, but the ones that I'm going to show you here today, I think will help show how this research is informing what land managers are doing and what they might be able to do a little bit better in years to come. So each of these graphs has herbicide on the x-axis. Most of them have year from 2021 to 2024. And then the variable that we're looking at, so cheatgrass cover, native plant cover, whatever it is. When we look at this particular graph, we're looking at cheatgrass cover. And again, do you remember that threshold I mentioned, that 5%? What we're seeing across this graph, even in untreated with the exception of 2022, which we still need to figure out what happened there, but cheatgrass is below 5% on average. In no year does it get higher than 5%. When we get into the detailed statistical analysis, we see that indaziflam has significantly lower cheatgrass than either imazapic or untreated. Imazapic has significantly lower than untreated, but the key trend is that indaziflam is decreasing over time across all 4 years, whereas imazapic, we're starting to see cheatgrass come back. That's what we were hoping for. But you can't really hope as a scientist, I guess. Yeah, hope is pretty important, but I guess, I don't want to bias these results. Okay, now we're looking at native species canopy cover. So within a 1/2 meter by 1/2 meter quadrant, what is going on with the canopy cover? How much is native? When we look at, so I'm going to mention the trend across all years without pulling out 1 year individually, and then get into kind of the nuance of the year by year. When we look across all 4, we see that untreated is no different from indaziflam, right? There's the same amount of native species cover in indaziflam and in untreated, but imazapic has significantly lower. So imazapic is having an impact on the native plant community. But immediately after herbicide treatment, so the first year after, we see that imazapic has significantly lower than indaziflam, which has significantly lower than untreated. So there's still an impact on the native plant community with indaziflam. It's just more immediate and it's more short-lived. When we look at native species diversity, which is different from canopy cover, this is Shannon's diversity index. So looking at the number of natives we have out there, but also the proportion of them. So in an area that has like 5 different native species, with each one taking up 20% of the canopy cover, that's going to have a much higher diversity index than a plot with 1 sagebrush plant that takes up 100% of the canopy cover. So it's a more complex look at native species, at what's going on with our native plant community. We see the same trend, though, as with canopy cover, that imazapic is having a greater impact on native species diversity. However, with the caveat that in 2024, indaziflam, for the first time, those plots had, for the first time, had significantly less native species diversity than untreated. And so this will be an interesting trend to continue to monitor in years to come. What's going on with native species diversity? Is the suppression of native seedling emergence by indaziflam having a long-term impact on the diversity of the plant community? Do there need to be additional steps taken when applying that herbicide? Okay, switching gears to seedling emergence. We'll only be on this graph for a second, but this is to reiterate our study approach. So we have 3 herbicides, 4 seed mixes. The first one is really no seed mix, that's our control. We're looking at seedling emergence. And then we also, not included on this graph, we also have that seed year variable that we seeded in 2 different years. we did plant both grass and forb seeds. It turns out monitoring grass seed emergence is really hard when you're in a pretty wild environment where there's like blue bunch wheatgrass sending out, like scattering its seeds everywhere, and you have Idaho fescue putting out like little runners. It's really hard to figure out what's going on with grass emergence, so I'm just gonna focus on forb because we're still untangling the story of graminoids. But if we just look at forb emergence by seed mix, if we look at all of the herbicides as one whole group, like without looking at the, without like diving into the specifics of one herbicide at a time, we see that there's significantly more germination with seed mix 2, 3, and 4 compared to seed mix 1, which our takeaway is, yeah, it's great. Even if you're applying herbicide, go out and broadcast seed. Broadcast where you're just throwing out seed at a consistent rate. But when we get into the more specific nuance, there's no difference in indaziflam, right? It's doing its job. It's suppressing emergence. There's like very little forb. There are very few forbs coming up in these plots. So maybe it's not great to seed in indaziflam plots because there's no difference between those that have no seed, seed mix 1, and those that have been seeded. In imazapic, when we run the analysis, seed mixes 2 and 4 do better than 1 and 3 significantly. But in untreated, seed mix 3 does better. And so we're starting to see that management really depends on the nuance of the situation. It's not like, oh yeah, go out, spray your herbicide, broadcast seed. It's like, okay, which herbicide are you using? And then let's move from there. And also, before even putting out herbicide, what's going on with your native plant community? How intact is it, right? If it's in pretty bad shape, it's gonna be a much harder comeback story with a lot more moving pieces. When we look at seed year, across all herbicides, seeding in year 2 results in significantly more germination. If we just look at indaziflam, there's no difference. Again, not a lot of emergence happening in indaziflam plots. Not super surprising. Whereas imazapic is a shorter-lived herbicide, and so over time, it's less effective and we have more emergence. I did find it interesting, though, that in untreated plots, there was more emergence in year 2. That might be a specific, might have to do with like the requirements of the individual seeds, right, when it comes to emergence. Okay, this is where I start to get excited, because this is our deep furrow, like last minute addition. When we look at deep furrows as a whole, all 3 herbicides together, there's a lot more emergence in deep furrow than in broadcast. Same thing when you look at just untreated or just imazapic or just indaziflam. That's likely because you're reducing competition, right? You're pulling away any like competing litter or competing canopy cover and providing a spot, a sheltered location for seeds to emerge. But what I found really interesting about this graph is we're still seeing the impact of herbicide, right? Untreated versus imazapic versus indaziflam. So even when you're digging 2+ inches below the soil horizon, there's still an impact. But if you're in an area that's quite degraded and you're looking to get native plant restoration going on the ground, deep furrows are a good idea, right? They're gonna contribute to more native emergence. As far as what happens with survival, that's another piece of the puzzle that you'll have to wait 5 to 10 years to hear. And, okay, so in summary, the herbicide application in the museum fire scar kept cheatgrass below 5%. That's awesome, because that's the threshold beyond which cheatgrass can contribute or can create much more dangerous wildfire dynamics. Native plant cover and diversity are within indaziflam pretty good, and imazapic recovering, but there's still more to this story that needs to be just uncovered with continued monitoring. In terms of seedling emergence, deep furrows are the way to go if we're looking to maximize emergence, but it does require more time on the ground putting in those deep furrows. And if you have the time and the resources, maybe the local students that want to help, one of the best ways to get native plants back in a really degraded landscape, or in a landscape that's in decent shape but has seen some recent disturbance, or is trying to deal with cheatgrass, and you've just sprayed herbicide, so seeding doesn't really work, planting native plant plugs is a really good route, because you're no longer you don't have to worry about the herbicide that's preventing seeds from emerging. So this is a local school group from the Kelly School. In 2021, they came out to the hillside above the museum and helped to plant 1,200 sagebrush plugs and 750 antelope bitterbrush plugs. And we strategically had them plant a certain percent of those at the corners of our plots so that we could monitor survival over time. When we look at the survival numbers that I calculated last year, haven't had a chance to dig into that data this year, we have about 50% survival of the sagebrush and about 35% survival on the antelope bitterbrush. Those stats are just so much higher, like orders of magnitude higher than what we're seeing in seedling emergence and survival. So this project has been it's been about a lot more than just collecting data and trying to inform land management. It's also been about engaging our community and creating a more resilient landscape. So not only did we have students out planting native plugs, but we've also had volunteers out on several different occasions planting natives around the National Museum of Wildlife Art. So instead of landscaping with non-natives, the entire museum is landscaped with native species that our volunteers and Teton Botanical Gardens have helped to plant. Along with those natives, there's now an interactive tour featuring native plants of the GYE. So there's a audio tour that folks can listen to as they walk around. And it also has information about the wildfire and what happened up there. So it's providing information about this cheatgrass cycle, but also about the power of native plants. We've also hosted a number of groups like native plant enthusiasts, the Teton Area TAWPAC, what is TAWPAC? Teton Area Wildfire Protection Coalition, which are a number of ambassadors that learn about wildfire dynamics in our landscape and then bring those lessons back to their communities and really support movement towards fire-wise landscaping or putting metal roofs on their homes, or understanding more why we're spraying herbicide out on all these hillsides. And then we also put together a native plant resource guide all about landscaping and restoration in Teton County and the GYE. And those are freely available. Teton Fire EMS actually has the PDF up on their website for folks who are looking to be more fire-wise, but also who are looking to plant more natives, because in general, the two tend to go hand in hand. And I do have a number of these with me if anyone would like one. Okay. This is balsam root, arrowleaf balsam root, Balsamorrhiza sagittata. It's a plant that I'd always admired prior to diving into this project, but I didn't really understand how iconic it is. It's one of the 11 seed species that we're tossing out on the hillside. And when it first comes up, it's like the size of a thumbnail. And that's it. That's all it does its first year. It takes 7 years at a minimum before balsam root will flower. And I think that really highlights that this is a long game that we're playing. It's not like a quick fix to bring back natives, but also there's so much balsam root still out there that we can protect and defend. And that's really the Defend the Core message, right? That we have an incredible suite of native species. We have over 1,200 native plant species in Teton County alone that we can continue to defend. And solutions like applying herbicide, but also knowing what the impacts are of herbicide and not being afraid to ask the hard questions or constantly reevaluate our management decisions are going to help us to continue to have a landscape like that looks like this. So, in closing, I'm going to read to you all what I wrote after, and is it Anaya Elizabeth Johnson? Dr. Anaya Elizabeth Johnson. I wrote it down wrong. But to her question, what if we get it right? So I wrote this when I got home yesterday. I imagine how our mountain town landscapes could look in the years to come. Our forests will carry less fuel, and species distributions may shift due to warming temperatures and changing precipitation patterns. Yet we will still see sagebrush, aspen, and Douglas fir trees. While cheatgrass and other invasives will remain, they will be in small, manageable populations that we address as a community. Our landscapes will support diverse perennial grasses, forbs, and shrubs that thrive throughout the season, providing essential food and habitat for native wildlife, like Hunt's bumblebees, calliope hummingbirds, and bears. But getting it right won't be easy. It requires collaboration, community involvement, constant evaluation, and addressing complex questions, like why we use herbicide and what the long-term effects are. It means native species and supporting organizing volunteer events where people come together to restore degraded land habitats by planting native species and supporting a restoration economy. It requires tackling difficult issues such as assisted migration and genetic diversity. Ultimately, it's about monitoring and safeguarding core habitats while also reevaluating what we define as core in a changing world. And perhaps most importantly, getting it right means drastically reducing our carbon emissions, because biodiversity, climate, and conservation are inextricably intertwined. So a quick thank you to some of our partners. There are a couple who aren't mentioned up here, but just want to shout out because this wouldn't be possible without a lot of collaboration and a lot of community support. And with that, I'm happy to take any questions.
Thanks. I'm curious, and you may have said this, but was there sage on that hill slope before the fire? And it just didn't come back at all, which is scary.
Yeah, great question. There was sagebrush on that hillside before. We have at least 3, maybe 4 different sagebrush species that were on that hillside. And now you can see the perimeter, right, of where that burn was and where the sagebrush is and where it isn't. We had Artemisia tridentata, Wyoming big sagebrush, Artemisia frigida, fringed sagewort, Artemisia tripartita, 3-tip sage, which resprouts after fire, so there's a lot more of that now. And then also Artemisia, I'm forgetting the Latin, but tarragon.
Yeah, I'm wondering how you do a study where naturally there are going to be good wildflower years and poor wildflower years. Take balsam root. Some years it's plentiful, and other years you hardly see much of it at all. And you also have the vagaries of climate, because this year it's been really dry.
Yeah, great question. Did you have a question, Phil? Okay. That is just an element of field science that we have to kind of run with, and that will enter our analysis. In years past, we have not had soil moisture probes in the ground there. This is the first year we've had those soil moisture probes with the help of the University of Wyoming. Ideally, we would have had those all along because we could throw them in our models and say, hey, how much was soil moisture, which is a product of precipitation and climate and temperature, how much was that impacting our results this year? Moving forward, we'll have that information. In years past, maybe there's some sort of well, it won't be location specific, but maybe we'll try and pull precipitation data from a nearby weather station and integrate that into our models to get a better picture of what's happening. But great question. Does that answer? Yeah, okay.
I can talk loud. Small room. This is amazing, and it's such a cool coordinated effort among so many different stakeholders. When you look at fires now that are burning 10,000, 50,000, 100,000 acres, like what are things that you can do locally to actually make a difference when you're talking on a scale that's just so overwhelmingly large?
That's such a good question, and one that I get kind of often because I do a lot of community outreach, and it feels like we're doing these smaller scale efforts. But I think one thing that you can do, super simple, is get involved in native plant restoration efforts. There are a lot of different groups that do them, or invasives management groups, like our local weed and pest district does a lot of those. I would hope to see, I think that in response to a lot of these bigger wildfires, as cheatgrass maybe invades those sites, there will be larger scale herbicide application, and that happens from a helicopter, so we can't really get involved with that, and you don't really want to be on the site the day of. But I would hope, like we're seeing a lot of energy right now being invested in native seed supply and in native plant strategy, and so as there are more resources available, I would hope, and maybe you as a community member can help push for this, but for native plant restoration efforts, not just suppression, but restoration. And so getting folks out on the ground with orange Jim Jams and plant plugs and going out there and planting, because at the end of the day, we need native seed to repopulate these burned areas.
Can I ask a second question?
Of course, all the questions.
I live on that butte, and we had 3 fires that same year, all of them cheatgrass related. Well, all but rusty parrot, I guess 2 out of 3. And I have been out gardening when drones have come over and sprayed where we are. But those drones don't come every year, and they don't come several times a year. And it seems to me, unless you spray pretty consistently, you're not going to get, reliable results.
Yeah, I'm gonna bring us back to the cheatgrass graph, just. Okay, so in Teton County, we're applying indaziflam. Indaziflam is a longer-term herbicide. So we're starting to see that it's effective in the soil for not just 3 or 4 years, but maybe even longer. That's no longer the case if the soil becomes disturbed. So if you're seeing cheatgrass emerge in like a new hillside, that's the result of a road cut or something. That's an area that would need to be retreated. But part of the appeal of indaziflam is that it only needs to be applied every so often, not every year. Again, there's an impact on native plant emergence as well there. But the goal with indaziflam is you only need those periodic applications.
Yeah, I get that one, but you've got another one.
Yeah.
Which needs more frequent application.
Yeah, so in Teton County, elsewhere we're seeing imazapic applied as well. Actually, now we're starting to see a dual application of imazapic and indaziflam. People are mixing them so that there's that quick, hardcore suppression and then a longer term from indaziflam. But in Teton County, we're only applying indaziflam. Yeah, thanks for highlighting that.
I don't know if everyone shares the same passion for sagebrush as we at the Nature Conservancy do. So, maybe you can just close by saying why the sagebrush stem is so important to the West and our communities.
Yeah. Oh, good point, Monica. I get a little bit, I don't know, rolling around in sagebrush in my head, even though I'm actually really allergic to it. It's like poison ivy on my body. I have some rashes right now because I was out planting it yesterday. Sagebrush, I think I just skipped over this because I didn't look at my notes at all. But sagebrush is a keystone species. In these habitats that are incredibly dry and arid, sagebrush provides habitat and food to a number of different species. You've probably heard about sage grouse being one of them, or pronghorn. When I'm out in the spring monitoring plant phenology, I see all the nettles, larkspur, and sagebrush buttercup, Indian potato. All of these plants are living around the sagebrush because they create microclimates where other plants can emerge and grow and thrive. Sagebrush has incredibly deep tap roots that brings up water from deeper in the soil. It also, in the winter, it's what we call the black body effect. We have UV light coming down, hits the sagebrush, which is often just kind of barely peeking through the snow. That turns into infrared, which then melts the snow around it, and that creates a source of water for other plants in the direct vicinity. Throughout the winter, there are small mammals living around the roots of that sagebrush where they're able to find habitat for forage. It is kind of the backbone of the biodiversity that the sagebrush steppe, this huge ecosystem, is able to provide. And so losing sagebrush has large implications for this beautiful landscape that many of us call home.
So what's killing it off?
So when we talk about the two main causes, I guess there are kind of three that are leading to that 1 million plus acres being lost annually. Cheatgrass fires. 2, development, whether that's for energy developments, unfortunately, or just expansion of other sorts of human infrastructure and homes. And then the third is agriculture, the expansion of agriculture. And I'm not saying sagebrush should be prioritized at the expense of everything else, but I'm saying it's a factor to consider when we're losing over 1 million acres annually.
One last question, sorry. Have you guys worked with the Audubon folks at all on their ranching conservation initiative? Because they're doing it with grasslands, and they assess ranches with like the riparian activity on there. A bunch of it's correlative with sagebrush, but talks a lot about sage-grouse. So I was just curious if you guys like collaborate at all in that space.
Yeah, I can't speak. I'm looking at Monica because I'm wondering if she has more information. I was at a gathering with someone from Audubon and the Golden Triangle, their work around the Golden Triangle. I know that we collaborate with them on in other states. I'm not sure about Wyoming specifically.
Yeah, we've been collaborating with Audubon on the new BLM's new sage grouse plan, and we're pretty aligned and in lockstep on that.
They have a really cool ranching program that works with private landowners to basically like make sure they're promoting riparian activity on land. So that just seems like a way to like get into that private land situation.
Yeah, that's a good point. Yeah,
Totally.
yeah. Thank you.
And then I think there was another question back there.
Yeah, I think you probably just answered some of my question, but how do you prioritize with cheatgrass being so rampant throughout the West? Like, how do I get Nature Conservancy to come to my community and do test plots on the cheatgrass?
So our research is really intended to inform management, right? So with the BLM just approved indaziflam application this year. They were still spraying imazapic until this year. And so our goal with this research is to inform ongoing land management practices. That said, our colleague Corinna, I still don't know how to say her last name. Reginos, thank you. She is doing this, she's actively looking at how do we prioritize where we treat and how do we monitor what's happening in the core, right? If we're saying ooh, this area is pristine and really, really, the sagebrush is perfect, there's no cheatgrass there. Well, when do we come back and monitor it? And how do we know if cheatgrass is invading? So knowing where to prioritize is a big question right now, especially in a state like Wyoming where we have low levels of cheatgrass invasion, but we're seeing cheatgrass in places we never have before. As far as managing cheatgrass on private parcels, that is more going to be a partnership or in relationship with local weed and pest district. They're going to be the ones making those, advising landowners on what to do, but we are going to be providing information to those weed and pest districts. Does that answer your question? Okay. Awesome. Oh,
I have another.
Yeah.
I am curious about, you mentioned the success rate on the 1 year on these sagebrush planting. Are you seeing, I mean, I'm right across the border in northwest Colorado doing work in California Park, which actually goes into, Slater Park goes into Wyoming. Forest Service systematically eliminated sagebrush to improve grazing habitat. But it's not coming back, even though they're not herbiciding it and others. But I've never heard anyone talk about trying to replant it. And just curious, does that make more sense? Does it? Because I've always heard that it's really difficult to get it to survive and take off. So it sounds like you're having some really good success.
We're having good success with plugs. There are a couple different nurseries that are included in this little book that I'll give you. We also, another body of our work at TNC in Wyoming has been partnering with DEQ, the Department of Environmental Quality, on mining lands that DEQ is looking to reclaim. And they've been a great partner with us in looking at different approaches to reseeding sagebrush on those landscapes, whether it's the amount of sagebrush seed being thrown out, or if it's trying to coat sagebrush in like carbon or something, or trying to throw sagebrush out with a little bit of extra fertilizer or nutrients to help the rate of sagebrush restoration on these landscapes. Because in Wyoming, there's a lot of open space where sagebrush has been removed, and it's a great opportunity, especially in these reclaimed mine sites, to try and bring back the sagebrush. What we're finding is sagebrush is stubborn and independent and doesn't like to be coated in anything. But if you throw enough of it out there and there's enough moisture, it'll germinate and take off pretty well. But again, these are landscapes that are like barren, so there's nothing to compete with.
If you go back to the slide where you highlighted the cheatgrass in the Teton Valley, is there a scenario, yeah, so that one on the left there, is there a scenario where if you create an ecosystem like that you want, will it eventually proliferate and help areas that you haven't treated that are infected with cheatgrass? Or is that sort of the dominant invasive species and you're always playing this game, this battle of it trying to come back into the native area? I don't know if that made sense.
I think so.
Okay.
Like, if you restore an area, does it become cheatgrass immune?
Well, and can it help other areas that are over that 5% threshold? Like, will it expand on its own?
I don't know if anyone's looked into that. And I can give you my card and follow up with you and look into the literature, because it's a great question. I do know that the goal with native plant restoration is to reduce the areas of that like interstitial space where cheatgrass can establish, but also there's increasingly a focus on allowing biocrust to regenerate, which biocrust is like basically living soil. And when there's a lot of disturbance, biocrust gets kind of eliminated, and that becomes an area for cheatgrass to establish. So with native plant restoration and soil restoration, you reduce the capacity of cheatgrass to invade. I don't know how, like, say you have way more blue bunch wheatgrass and Idaho fescue and sagebrush, does that start to spread? I don't know the answer to that, but I would guess there are some folks at the University of Montana looking into it, because they're doing a lot of great research right now. Any other questions?